Welcome back to my online teaching platform. We are to find the limit of the function 1 out of x as the input x approaches negative infinity. We have answered a similar question, but that one, the x or the input approaches positive infinity. So let us look at how best we can answer this particular question as the input approaches negative infinity. So let us use our number line. So here we can see that we have our number line. So let us indicate our 0 here, and this side will be our negative infinity, where here will be our positive infinity. Let me write it well. All right. So we have our negative and that of our positive infinity. So we are to determine what the output, that is the y value of the function, will approach, the value that the y value of the function approaches as the input, which is the x, approaches negative infinity. So let's say we have negative 1 here, we have negative 2. Let us continue. Suppose we have negative 10 here, we have negative 100 in that order. So we are going to verify, we are going to test to see the number that the output y will be approaching as the input x approaches negative infinity. So let us look at that one and see how best we. So we have it as lim, that's the limit of the function 1 over x as the input x approaches negative infinity. Now, so let us test for the first. Let us assume that the first value of x is negative 1. So if x is negative 1, you plug in negative 1 for x. So wherever you see x, you put negative 1 over there. So we are going to get the result to be negative 1. If x is negative 2, we are approaching negative infinity. So you pick the numbers in that order. So the numbers that you are picking for x should rather decrease, not increase, because negative 2 is less than negative 1. So as you are approaching negative infinity, the numbers that you are picking should be smaller or should be getting closer to negative infinity. So let's test for that of if s is equal to negative 2, you are going to get negative 0, you will get negative rather, so you get negative 0.5. Now let's test for the other one. Let's assume that x is equal to 10. So if x is equal to 10, you are going to get 1 divided by, sorry, x is equal to negative 10. So 1 is going to be 1 divided by negative 10, and that will give us 0. I've forgotten my negative again. So it will be negative 0.1. But we divide the same 1 by, we are going to get 1 over, suppose x is negative 100, we are going to get negative 0.01. So you will see that the numbers that we had moves from, we have negative 1, we also have negative 0.5, we also have negative 0.1, we also have negative 0.01. Now, you could see that the numbers over here, when it comes to a negative side of numbers, the smaller number is rather bigger. Yes, the one with the smaller value is rather bigger. So negative 1 is rather smaller than negative 0.5, and negative 0.5 is also smaller than negative 0.1. So negative 0.1 is also smaller, or is also less than negative 0.01. So when you consider the numbers over here, the one that is very big, or the biggest among them, is negative 0.01. And you can see that that's the number that is very close to 0. You can see that the numbers are getting, as we continue to divide by negative values that are approaching negative infinity, the values that we are getting get closer to 0, because negative 0.01 is closer to 0 than negative 0.1. a negative 0.1 is also closer to 0 than negative 0.5. So you could say that as you divide by a number that is approaching negative infinity, the value that you obtain is also getting close to 0. So we conclude that the limit of the function 1 out of x as the input x approaches negative infinity. Hey, I'm forgetting my negative. Negative infinity will be equal to 1 over negative infinity. So it means we don't know the actual value that we are using to replace the x, but the assumption is that the number is approaching negative infinity. And you could say as the number is approaching negative infinity, we are getting the same negative values, but you could say the negative values are becoming bigger, which means they are very close to the 0. So yeah, we are going to get it to be 0. So we conclude that if you have the limit of 1 divided by x as the input here, that is the x approaches negative infinity, the answer is 1 out of negative infinity, and that must be equal to 0. So that's the answer for this problem. So the limit of the function 1 out of x as the input approaches negative infinity must give us 0. All right. Thank you for watching.